The last type of fuel I'd like to talk about comes from nuclear power. And as I said, pretty much all of the sources of energy that we use today come from either geologic materials or geologic processes. And nuclear power is one that actually comes from a geologic material. It comes from uranium. Okay, so how does a nuclear power plant work? Well, the energy that drives nuclear power plants comes from nuclear fission. This is the exact opposite of nuclear fusion that we learned about when we talked about the Big Bang and how atoms are created in stars. Okay, so whereas nuclear fusion was when two smaller atoms combined to create a larger atom, nuclear fission is when a larger atom is ripped apart. Right? So the nuclear bonds that hold the protons and the neutrons together in the nucleus are ripped apart. And when that happens, when that atom is split up into smaller pieces, that small amount of mass transforms into thermal and electromagnetic energy, right? Heat is released, and that's the energy. So within a nuclear power plant, there's a nuclear reactor. That's the heart of the plant. And it has to be reinforced by concrete, right? And the fission reaction involves uranium, right? So we take uranium atoms, through nuclear fission, we rip those uranium atoms apart, and that produces heat. And that heat transforms water into steam. That steam rotates fan blades, and we produce electricity that way. Now, compared to fossil fuels, the energy density of enriched uranium is vast. 1 gram of reactor fuel contains almost 80,000 times as much energy as 1 gram of gasoline. And can you imagine 1 gram of gas versus 1 gram of nuclear reactor fuel? That nuclear reactor fuel is going to be 80,000 times. It's going to have that much more energy, right? And on top of that, it doesn't yield any air pollution or other greenhouse gases, right? So we're not releasing carbon into the atmosphere when we're doing that because we're not working with carbon, we're working with uranium. So nuclear power plants could theoretically produce a large proportion of the global energy supply. But at present today, they don't, because we have concerns about handling nuclear fuel and nuclear waste. Right? So they don't produce greenhouse gases, so they don't increase climate change. However, we do have to deal with dangerous fuel and dangerous waste and how we store that fuel and waste. We're working through that as a society. All right, so I said that nuclear energy, right, comes from a geological material. It comes from uranium. So where does uranium come from? Well, it's one of Earth's radioactive elements, and they were developed during the explosion of supernova, right, when stars explode, that happened before the existence of our solar system. Okay? So when those early stars exploded in supernova, uranium atoms were formed and then blown out into space so that they were then available to be incorporated into our planet. And that is why Earth's crust contains uranium. That uranium was formed billions and billions and billions of years ago in another star's supernova and now is contained in Earth's crust. We extract it from Earth's crust. It undergoes nuclear fission, and that's how we get energy from that uranium.